Every time a natural disaster hits or, a global supply chain completely breaks down, the very first people called to action aren't the politicians.
Right, definitely not.
No, they're geospatial technicians.
Yeah.
And today we are opening up the digital blueprint that trains that exact invisible army. Welcome to your custom-tailored deep dive.
Yeah, we've got a really fascinating stack of information today. It basically looks like the master directory for a very dense, link-heavy internal sitemap.
Yeah, a bulletin from an organization called the Geotech Center.
Exactly. And looking closely through this directory, it's immediately clear this isn't just, a basic list of links.
Right.
It is a highly comprehensive framework detailing exactly how the United States is attempting to upskill an entire generation of spatial data workers.
Okay, let's unpack this.
Okay,
Because
cool.
anyone listening right now already knows we are living in a fundamentally data-driven world, right?
Absolutely.
We know geospatial technology is the unseen infrastructure. It's running everything from satellite imagery analysis to autonomous drone mapping.
Yeah, and just to set the baseline here, when we say geospatial technology, we're talking about the nuts and bolts of mapping.
Right.
It's spatial data, it's drones, it's geographic information systems. But what this source material really reveals is the massive machinery operating behind the scenes to actually teach those complex skills.
Exactly. We are looking at the ultimate toolkit for anyone looking to understand or learn or teach this rapidly exploding field.
And that explosion in workforce demand is really the catalyst for everything we are going to explore today. The industry is just scaling so incredibly fast.
It's moving at warp speed.
Yeah, and the traditional academic pipelines, your standard four-year universities, they just cannot output graduates fast enough to keep up with the sheer volume of open positions.
Which honestly perfectly explains the first major piece of news hidden in this bulletin.
Yeah, the big transition.
Right. So the Geotech Center, which is currently physically based out of Jefferson Community and Technical College in Louisville, Kentucky, is undergoing this massive institutional evolution.
A huge one.
Yeah, they are officially transforming into the Geospatial Technology Consortium of Community Colleges, GCT3.
And they are backing up this evolution with a staggeringly impressive roster of funding. I mean, we were talking about at least 8 distinct National Science Foundation grants.
8 of them. Wow.
Yeah, stretching back over a decade. And if we connect this to the bigger picture, the National Science Foundation does not continuously fund a single center with 8 sequential grants without expecting a highly scalable return on investment.
Right. They want results. So the transition to GCT3 is really a direct structural response to that national workforce shortage.
Exactly. It's about scaling up.
I see the scale of it, but I have to ask, why build this massive national consortium out of community colleges?
Well, it's a fair question.
Like, if you have all this NSF money and this critical national mandate, why not run this operation out of MIT or Stanford?
Because the specific types of roles the industry desperately needs to fill right now, the GIS technicians, the field drone operators, the spatial data analysts, they don't necessarily require a 4-year degree.
Or the massive student loan debt that comes with it.
Exactly. They require intensive, targeted, practical skills training. And community colleges are uniquely positioned to be agile enough to provide that.
Okay, that makes sense. So it's like the Avengers Initiative for community colleges.
I love that analogy.
Yeah.
Because the historical problem has been isolation. A great community college in Kentucky might have an amazing GIS program, but a rural college in Oregon might be struggling to build a basic syllabus.
So they're just completely disconnected.
Right. So GCT3 pools all that regional brainpower, the individual grants, and the technical resources into one unified national force.
It's taking these isolated pockets of regional excellence and standardizing them from coast to coast.
Precisely. And standardizing an entire national curriculum for a technical field that changes, well, almost weekly is a monumental task.
And that task clearly requires a massive blueprint. Which brings us to the next section of our deep dive. When I was reading through this bulletin, I hit an absolute wall of academic jargon.
Oh yeah, it gets pretty thick.
Extremely thick. We're talking about heavy references to the GTCM, the GTCM DAICMs, and something called the MetaDAICM.
It's a lot of acronyms.
And then it mentions a new geospatial tools self-assessment tool alongside a personal assessment tool. I mean, I have to push you to cut through the red tape here.
Sure, let's do it.
When I read a phrase like MetaDAICM, my eyes literally glaze over. Is this actually useful for a learner? Or is it just, bureaucratic, busy work generated to satisfy grant requirements.
It definitely sounds incredibly bureaucratic on the surface. But what's fascinating here is that those dense acronyms are actually the high-performance engine of the entire national program.
Wait, really? The engine?
Yeah. Let's break down the mechanics of it. GTCM stands for the Geospatial Technology Competency Model.
Okay.
And to actually build that model, educators use a process called GCT3, which stands for Developing a Curriculum.
Okay, so how does that process actually work in the real world? Do a bunch of professors just sit in a conference room and guess what should be on the test?
That is exactly what the GCT3 process prevents, actually.
Oh, interesting.
Yeah, it is an intensive, highly structured workshop where educators take a back seat. Instead, they bring in the actual current expert workers in the field.
Ah, okay, the people actually doing the jobs.
Right. They sit down with the people actively flying the survey drones, the professionals running the urban spatial analyses, and they mandate that these workers define the exact granular duties and tasks they perform every single day.
So a metadacum is taking all those highly specific, localized job analyses from different regions and like rolling them up into one master national blueprint.
You've got it. It prevents a scenario where a well-meaning educator spends a whole semester teaching outdated topological map-making software that the commercial industry abandoned 3 years ago.
Right, because you don't want to spend 2 years learning how to draw paper topographical lines when the modern industry is asking for technicians who can write custom scripts for autonomous drone swarms.
Exactly. That is the exact educational trap the GPCM is designed to avoid.
Well, that makes the inclusion of the new self-assessment tool suddenly make a lot of sense.
How so?
Well, when I was reading about how that specific tool functions, I immediately thought of playing a role-playing video game.
Oh, like checking your stats.
Yes. You know when you pause the game and check your character's stat sheet? You see, like, okay, my agility is at a level 10, but my mapping magic is only at a level 2.
I love that.
It feels like this self-assessment tool is exactly that, but mapped onto the GTCM for your real-world career. You plug in your current technical skills, and it shows you exactly where your stats need leveling up to match what the industry actually wants.
That is a brilliant way to conceptualize it. The competency model is the underlying code that makes the game work.
Right.
It defines what a level 10 spatial analyst actually looks like today, completely removing all the guesswork for the student.
But having that master blueprint is critical, but a blueprint doesn't actually build the house, right? The consortium has to deliver this training to the public. And looking at the resources they offer, they are pushing out an incredible amount of material. There's a syllabi repository, model courses, and a geospatial awareness MOOC.
Yeah, the MOOCs are huge.
But here's where it gets really interesting. They specifically highlight a UAS MOOC that's uncrewed aircraft systems, focusing on drone safety and application.
Right.
And something called the Arcade Expression Crash Course. Plus, they detail deep operational partnerships with the National Center for Autonomous Technologies and the Environmental and Natural Resources Technology Center, known as EARTH.
There is a massive shift happening in those specific educational offerings.
Mm-hmm.
And the first thing to note is the format itself.
You mean the MOOCs?
Yeah, MOOC is a massive open online course. This democratizes the knowledge entirely. You don't have to navigate the admissions process of a multi-year degree program to access this material.
That's amazing. And they are teaching some highly advanced niche concepts in these accessible formats, like take the Arcade Expression Crash Course.
Oh yeah, that one's fascinating.
The source material just drops that name, but what actually is arcade expression? Because to an outsider, it sounds like something you do at a vintage pinball machine.
It really does sound like that. But arcade expression is actually a lightweight, incredibly powerful scripting language developed specifically for ArcGIS.
And that's a big deal software.
Oh, it's the absolute industry standard software for spatial mapping. Arcade allows map makers to create highly customized visualizations and data labels on the fly.
Wait, so instead of just looking at a static map, you're like programming it.
Exactly. Instead of just rendering a map that statically shows city temperatures, you can write an arcade script that tells the digital map to actually react.
React how?
Well, you could say, if the live temperature data in this specific zip code crosses 100 degrees, automatically turn this region bright red, pull in census data, and instantly calculate the population density of senior citizens living within that boundary.
Oh, wow.
Yeah, it turns a static image into a highly dynamic, reactive analytical tool.
That is wild. It's basically giving the map a brain so it can execute complex math for you in real time.
Exactly.
And then you combine that software logic with the hardware side, the UAS MOC, the drone training. The source links this hardware training directly alongside the Earth Center partnership.
Right, the Environmental and Natural Resources Technology Center.
Yeah. So how do the drone and the environmental center actually fit together in practice?
Well, this raises an important question about how we actually procure the raw data to feed into those smart maps we just talked about.
Oh, right. Where does the data come from?
Exactly. We aren't just relying on giant, expensive government-operated satellites anymore. Modern geospatial tech is about actively gathering autonomous, hyper-local data from the sky.
So that's where the drones come in.
Yes. The MOOC teaches the safety and flight operations of the drones, but the application part is where Earth comes in. We were talking about using drones equipped with LiDAR.
Which is the technology that uses pulsed lasers to measure variable distances to the Earth, right?
Correct. You use LiDAR, or advanced photogrammetry, to create high-resolution 3D models of a physical environment.
Okay, give me an example.
So you fly a drone over a dense forest canopy, and the LiDAR penetrates the leaves to map the exact density of the wildfire fuel loads on the ground.
That is incredible.
Or you use autonomous tech to analyze the infrared signature of agricultural crops to determine exactly which specific rows need water, down to the centimeter. It conserves massive amounts of resources.
Wow. So that partnership with Earth proves that learning geospatial tech isn't just some abstract academic exercise in geometry.
Not at all.
It is the absolute front line of managing the planet's physical resources. It's actively managing the world, not just observing it.
Perfectly said.
But let's take that a step further, because this brings up a massive practical challenge. We've got the digital classes, the LiDAR drone technology, the scripting languages. How do these educational tools actually translate into someone getting hired, especially for, non-traditional students who have deep hands-on field experience, but maybe lack the traditional civilian paperwork?
That's a huge hurdle for a lot of people.
Right. And the source material outlines geospatial careers guidance, a mentoring program, and extensive veterans resources. But the tool that stands out the most is the military crosswalk of competencies.
That one is so important.
Break this down for me. How does a crosswalk function here, and how does a veteran translate their highly specialized combat experience into these civilian GTCM standards?
Well, a crosswalk is essentially a translation matrix. And in this specific field, it is an absolute economic necessity.
Why is that?
Because the military is one of the largest consumers and drivers of geospatial technology on Earth. They use it for complex logistics, battlefield intelligence, and global navigation.
Right, of course.
But the military uses its own deeply entrenched operational codes and terminology. Take an Army MOS code like 12Y, which is a geospatial engineer. That veteran might have thousands of hours of experience running complex spatial analyses in a high-pressure combat zone. But their official military paperwork might not contain any of the corporate keywords a civilian HR algorithm is looking for.
Oh, so the algorithm just sees military jargon, assumes a lack of relevant civilian software experience, and just tosses the resume.
Exactly.
Even though the candidate is vastly overqualified.
Precisely. So the military crosswalk takes those specific military occupational codes, like the 12Y, and maps them directly, point by point, onto the civilian GTCM competencies we discussed earlier.
Oh, that's brilliant.
Yeah, it explicitly tells the potential employer this specific military intelligence code directly equates to these 5 civilian spatial analysis competencies. It bridges that resume gap instantly.
It just translates their service into immediate market value. That makes perfect sense in theory, but I have to push back a little on the execution of that matrix.
Okay, go ahead.
Military tech procurement moves incredibly fast, but civilian software updates just as rapidly. How useful is a crosswalk if it isn't constantly updated to reflect the current versions of these tools?
That is the exact operational challenge.
Yeah.
And honestly, that is why the GCT3 Consortium model is so vital to this effort.
Oh, tying it back to the big evolution.
Yes. If one local, underfunded college tries to maintain that crosswalk alone, it goes out of date in 6 months.
Right. They just don't have the manpower.
But with a unified national consortium fueled by those sustained NSF grants, They had the infrastructure to constantly run new DACM panels.
Oh, so they continuously update that crosswalk so it reflects the absolute cutting edge of both military and civilian technology.
Exactly. It ensures the bridge remains structurally sound year after year.
And speaking of expanding networks, there was another fascinating link buried in the career and mentoring resources. The source points learners directly to the International Charter Space and major disasters.
That inclusion is a brilliant piece of instructional design by the Geotech Center.
It really is because it immediately scales everything up. We are talking about local community college courses, but this links the curriculum to a massive, highly consequential global network.
Yeah, for context, the International Charter Space and Major Disasters is a worldwide collaboration of space agencies.
It sounds like something out of a sci-fi movie.
It kind of is. When a massive catastrophic event occurs like a tsunami or an unprecedented earthquake, agencies from all over the globe agree to instantly open up and share their proprietary satellite data to aid in the rescue and relief efforts.
Wow.
And by embedding this into the Geotech Center's professional resources, it sends a very clear, powerful message to the learner.
Which is?
The foundational skills you are picking up in a free MOOC in Kentucky or Texas are the exact same analytical skills needed to process global satellite data and map a disaster zone halfway across the world.
It connects the local community college learner to a highly urgent global mission. That is so empowering.
It really is.
But, you cannot build a globally connected, highly skilled workforce entirely in the cloud.
No, eventually you need human interaction.
Right. Eventually, these educators, professionals, and technicians need to physically get in a room together. They need to debate these evolving standards, share their new archaic expression scripts face-to-face, and figure out how to teach the next wave of students.
Which perfectly explains the final major piece of our source material today. GeoEd 26.
The physical gathering of the community, yes. GeoEd 26 is a 3-day professional development conference running from May 30th to June 1st.
With optional pre-conference intensive workshops on May 28th and 29th, right?
Exactly. And the event will also feature the Excellence in Geospatial Education Awards. But here's the detail that truly stands out to me.
The price.
The price. It is completely free to attend. I mean, I look at a lot of tech conferences, and usually a comprehensive multi-day professional development summit is going to run you hundreds, if not thousands of dollars just for the entry badge.
It is incredibly rare in the professional tech world, and it is a deliberate, highly strategic choice. Well, think about it. If the overarching goal of the GCT3 is to standardize this cutting-edge curriculum across every community college in the country, you simply cannot put a massive financial paywall in front of the educators who desperately need to learn it.
Oh, of course.
By making GeoEd 26 free, they are ensuring that an educator from an underfunded rural community college can sit in the exact same room as the leading commercial drone operators and national spatial analysts.
That levels the playing field so much. And look at where they are hosting it, too. It's located at the Dallas College Brookhaven campus in Dallas, Texas.
Right.
They aren't renting out some luxury corporate resort in Vegas or holding it behind the ivy-covered walls of an elite private university.
That venue choice is the physical embodiment of their entire educational philosophy.
They're literally walking the walk.
Exactly. They are hosting the National Summit at the exact type of accessible institution that is doing the heavy lifting for this workforce.
And those Excellence in Geospatial Education Awards they mentioned, that isn't just about handing out decorative plaques.
No, it has a real function.
It's about taking the best, most innovative teaching methods developed at one local college, putting them on a national pedestal, and allowing every other educator to take those methods back to their own classrooms. It accelerates the entire national curriculum.
It's a feedback loop of excellence.
Absolutely. So what does this all mean for you listening right now? Let's trace the massive arc we just took through this digital directory.
We covered a lot of ground.
We really did. We started with the evolution of a single regional center into the GCT3, a massive national consortium fueled by NSF funding to tackle a critical workforce shortage.
Then we decoded all that heavy academic jargon to find the GTCM, the master blueprint that ensures no one wastes time learning obsolete technical skills.
Right. We explored how that blueprint is put into action through deeply accessible MOOCs, teaching everything from the arcade expression scripting language to the autonomous LiDAR drone data collection that powers environmental conservation at the Earth Center.
And we saw how the military crosswalk translates complex combat experience into civilian spatial careers.
and how local community college training plugs directly into the global disaster response network of the International Charter.
Yeah.
And finally, how all of this culminates at the free, community-driven GeoEd 26 conference in Dallas. It is an incredibly robust, deeply empowering ecosystem of education.
It really changes the landscape of how we think about tech education and accessibility.
And the best part is, these resources are just sitting there freely available for anyone ready to master the technology that is actively managing our world.
And if we connect all of this to the bigger picture, I want to leave you with a final thought to mull over.
Okay, let's hear it.
If a standardized framework like the GTCM can perfectly map out the competencies needed for geospatial technology, what would a competency model look like for your own current job or passion?
Oh, wow.
Yeah. How much faster could you reach your goals if you had a literal map for your own career path?
That is a phenomenal question to chew on. Something to keep in mind the next time you look at a digital map or, the next time you look up and see a drone charting the landscape above you. Thank you so much for joining us on this custom-tailored journey today. Keep digging, keep asking questions, and stay curious. We'll catch you on the next deep dive.